Algebra 1, Lesson 84, multiplication of radicals and functions. So multiplication of radicals is not that difficult. All we have to know is what happens if we have something like square root of 3 times square root of 2. So quite simply, if you have to multiply two radicals, you can just write them as being, sorry, having focusing problems again. You just multiply the numbers and then put them both under a radical. So 3 times 2 is 6, and so that would equal the square root of 6. So multiplication of radicals isn't too hard. Now what if we have numbers like this, like 4 times the square root of 3 times 3 times the square root of 2? What does that equal? Well, we're just going to do it separately. We'll multiply the whole numbers. 4 times 3 is 12, and then root 3 times root 2 is root 6. So that's pretty simple, right? Now, what if we get one of these problems in a set of parentheses where we'd have to use a rule like distributive property? So they give us the example, 4 times the square root of 2 times 3 root 2 plus 5, okay? So we're just going to use distributive property. This times this, and this times that. Now, 4 times 3 root 2, 4 times 3, it's going to be 12. Root 2 times root 2 is going to be square root of 4. And then plus 5, 4 times 5 is just going to be 20. And then square root of 2 gets tacked on at the end. All right. Now, is this our final answer? No, because we can simplify this radical, square root of 4. Square root of 4 is actually equal to 2 because we factor, we have two 2's. So this is actually 12 times 2. So this becomes 24 plus 20 times the square root of 2. And that's as simple as it can get because we cannot add these. These are not like terms. So that would be one answer. Let's do another example. Let's say we have 4 times the square root of 3 times 5 times the square root of 2 plus 6 times the square root of 3. What does that become? So, distributive property again. Four times 5 gives me 20. Root 3 times root 2 gives me root 6. 4 times 6 gives me 24. Root 3 times root 3 gives me square root of 9. Or we could see this is the same root times itself. That's just going to be the number 3. So I'll put that in parentheses. So what I did there is I just kind of simplified and I used another rule, which is that if you have the same root times itself, that's just going to equal the number. So square root of 3 times square root of 3 equals 3, or we could view it as square root of 9 is also equal to 3. From there, we're not done. We have to finish simplifying. 3 times 24 is going to give me 72. So we have 20 root 6 plus 72. However, we want to write our numbers in, we want to put them in what do we call it? I forgot the order. Logical order, right? We want to put our most certain number first, which would be the whole number 72 plus 20 times the square root of 6. So that's how I would write my final answer. If you forget that, that's fine, but eventually you'll get used to putting the whole number first and then the radical second. So that's multiplication of radicals. Now let's talk about functions. So to do this, I need to go to the book. Now, when we're talking about functions, we're talking about different equations that if we were to plug a value into, we would get an answer. A good example of this is linear equations like y equals mx plus b. But a function is pretty much any algebraic expression that can be represented on a graph or a coordinate plane. And pretty much if you plug in a value for x, you'll get an answer for y. So sometimes they're referred to as a function machine because we put a number in, the machine spits out an answer. Put in a number, get an answer. Now the thing about functions is the values that you put in. So what we see here is a graphical or a little bubble relationship of what makes something a function. Now in order for something to be a function, if you plug in a value, you must get an answer, right? Now two different values can have the same answer. That works for a function. Or we have this, which is where each value gets a different answer, right? Now, what is not a function is one value cannot get two different answers. So the example we see here is that if you plug in the number 4, And if you get two possibilities, you know, where if you plug in the number 4 and the answer 3 or 5 are possible, that's not a function anymore. Now, the other thing that's not a function is if you plug in a value and you get no answer. Here we plugged in 1 and there's no answer for 1. So that's not a function either. Another way to see this is in coordinate pairs. So here, and then the way you would view that is the left side is the x-axis, the right side is the y-axis, right? So this could be the coordinate pair 4, 3, 2, 3. That would work. So what we see here in this set of coordinate pairs is we see a bunch of different x values. The x values being 4, 5, 9, 4, 8, and 6. So this would be like the left-hand bubble, all the x numbers. The right-hand bubble would be the numbers 3, 7, 3, -5, 14, and -3. So what we want to do here is we want to make sure that we're following these rules, which is that two x's can have the same y value. However, if one x has two different values for y, then it's not a function. So let's look at this. We're going to look at our x's and we'll see if we have any repeats. I see 4, 5, 9, 4. Oh, 4 again. I have two 4s. Now, do the y's match? This one is 4, 3. This one's 4, -5. These y's do not match. I cannot get two different answers for the same x. So this is not a function. These points do not represent a function. Let's look at this next set of sets right here. We have 4, 5, 9, 4 again. Now this one does work because both of the 4s have the same answer. All right, so this is consistent. This works for a function. Now let's see here. We also have 8 and 6. All right, none of these x's repeat except for the 4s, and the 4s have the same answer, so this is a good function. Now you may notice the 9 also has an answer of 3, but that's okay because, like we showed up here, we can have two different x values with the same answer. That is okay. So the bottom one is a function. Okay.